The Monroe CVSA is a dual-tube shock absorber, electronically adjustable through an electronic lateral valve. In reality, if you open the shock absorber, you will see that there are 3 tubes, 1, 2, and 3, but doesn't matter. We have to consider it as a twin-tube shock absorber. The components of this shock absorber are, as in any other shock absorber, the rod. In this case, is not hollow. A rebound spring, a rebound stop, and a standard piston. Then, here, there is the bottom valve. There are many types of Monroe CVSA. Depending on the application, there is a different bottom valve, but we will see this detail later. Then, there is the main cylinder, the second cylinder, the body, the electronic valve with the solenoid. Then, here, we will see it in detail later when dismounting the shock absorber, there is the guide. So, how does it work, this shock absorber? Into this shock absorber, we have oil into the inner cylinder, oil into the first chamber, and oil into the second chamber, more or less within the half or the 2/3. Then we will have nitrogen. It works as any other shock absorber. So in compression, when I push down the rod, I create a pressure between the piston and the bottom valve, and a vacuum between the piston and the guide. Because that, an amount of oil equivalent to the volume of the rod crosses the bottom valve and goes out. Another amount of oil equivalent to the volume of the cylinder less the volume of the rod crosses the piston. Then, in rebound, vice versa. An amount of oil equivalent to the rod returns into the main cylinder, while an amount of oil equivalent to the cylinder less the rod is crossing the piston. In rebound, we have a pressure between the guide and the piston, and a vacuum between the piston and the bottom valve. Now, when this guide has some special holes, we will see them later, allowing the oil into the inner cylinder to pass into the first chamber. So suppose that you push the rod out, the pressure will oblige the oil to pass through the guide, and from the guide, through special holes, to pass here and to come to the adjusting system. If the adjusting system is closed, all the oil is forced to pass through the piston, and in this way, we have the maximum rebound force. Suppose that we open little bit the adjusting system. The oil can pass through the adjusting system, and the amount of oil crossing the piston decreases. So, more we open the adjusting system, and more oil escapes from the piston, and softer will be the shock absorber. In compression, it's the same thing. Remove the solenoid using a guillotine. First, mark the position of the solenoid with respect of its housing, and using the tool Emetec Zeta 09010 or similar, cut off the solenoid. And finally remove the internal components, like the circlip indicated with a red arrow, the O-ring indicated with 4 black arrows, and any eventual remnant of the solenoid. Or do the same procedure using a hammer and a scalpel. With the hammer and the scalpel, break the solenoid. Within, remove it. Remove the electronic valve using the proper tool. It could be the 98521 or 517. Look for the right one. It depends from the shock absorber you are dismounting. Engage the pins of the tool into the holes of the valve. And then unscrew within removing the side valve. Pull the side valve out as well as the rest of its components. And now remove the oil inside. Then open the shock absorber on the Mangusta or on the lathe machine. Remove the inner parts, the guide from the inner cylinders. Be careful with the oil inside. Remove the rod and the piston. Some oil can escape. Remove the rebound spring and any other part from the rod. Modify yourself a pipe, creating a tool for disassembling the two cylinders from the inner one. In this way, you can disassemble the outer cylinder from the inner one, and now with a punch, disassemble also the bottom valve from the inner cylinder. We will analyze the bottom valve in the next tutorials. There are many different types. If needed, dismount the piston, disassembling all the parts, clean them, and fit them again, respecting the original order and position. These shims create the bypass of the piston. Look to the piston and remember its position, because you cannot mount it upside down. Now clean each component and mount it again, respecting the original position. Again, remember the original position of the piston and respect it. Respect also the position of the two first shims in order to keep always the same bypass area. At the end, fit the nut, screw it, and tie it with the tool. As with any other twin-tube shock absorber, reassemble all the shock absorber components, including the overhauling kit, but without oil. Then, measure the protrusion of the thread ring. Shorter the inner cylinders on the upper side, only on the upper side, not on the lower side. Be careful. Check if the shock absorber closes correctly. And if everything is okay, then you can disassemble in order to assemble again, but with oil. Let's see how. Aligning the inner cylinder with the body using the proper tool. Otherwise, if you mount the shock absorber using the electronic valve from the beginning, you risk to break it when tightening the thread ring. Be careful. Use always tools 98518 or 98519 depending on the application. Otherwise, there is the serious risk of breaking the electronic valve. Feed the bottom valve into the inner cylinder and the inner cylinder into the second cylinder, respecting the original position of the bottom valve in comparison with the second cylinder. Block the body of the shock absorber on the vise and fit the two cylinders in it. Fit the rebound stop, the rebound spring, and the rebound stop again on the rod. Leave them ready to be mounted. Then move the body in an horizontal position blocking it into the vise, and center the two cylinders respect the body of the shock absorber. When it will be possible to fit the washer, the position will be mid. Now look for the data sheet of the proper kit into the Emetec Proto Catalog. And based on the code, choose the kit. In this case, the kit is the 5049459. Open the bag, being careful do not damage the sealing components. Pull out the components of the kit as indicated on the Proto Catalog. The thread ring, the centering ring, the oil seal, the bushing, the rebound stop, it is suggested to replace the rebound stop in order to leave the original stroke of the rod. As well, it is suggested to replace always the bushing and the scraper. Then, depending on the model, fix the inner cylinders using the tool 98518 or 98519. In this way, when closing the shock absorber, you will not damage the valve. Put the shock absorber in a vertical position. And fill the oil in. The inner cylinders must be full of oil. And when pushing in the rod, the interspace must be full of oil for a 50% of its length, 50, 60, 70% depending on the shock absorber. So, with the inner cylinder full of oil, push the rod in and look to the movement of the oil. Proceed checking if the bottom valve is clean and if its bypass is balanced with the piston one. To do it, push the rod in. If the oil rises along the inner cylinder, keeping it full or almost full, it means that the piston in compression is softer than the bottom valve in compression, as it must be. If, on the other hand, pushing the rod in, the oil rises along the interspace and the internal cylinder tends to get empty, it means that the piston in compression is harder than the bottom valve in compression, which will generate gaps in rebound and therefore noise. This situation must be avoided. If that happens, means that the bottom valve very probably is dirty. So you have to dismount and clean it as shown in the next tutorial. If everything runs well, we finish to mount the shock absorber with the rebound stop, the spring, the rebound stop again, then the guide, being careful to center the three cylinders, block it in, remember that the thread must be long enough to ensure that the thread ring will block the guide before reaching the end of the thread done on the body of the shock absorber. In any case, the O-ring or the lip of an oil seal draw 11 must work on a smooth area, otherwise will be damaged and the shock absorber will drop oil. Now fit the oil seal. There is the space, a smooth space to fit the O-ring, so it will work in a right position. The O-ring must have a round shape and seal all around. Now, the centering ring has to create a housing for the O-ring in order to avoid it to get deformed when pressed with the thread ring. Now extend the rod because we have to close the shock absorber with air in order to avoid rebound gaps. Tie it with a short compass tool and then with a longer one. Move the shock absorber in an horizontal position in order to have oil down and the bubble of air on the top. Now we can remove the centering tool because all the parts inside of the shock absorber are tight, centered and tight. So we can remove this centering tool and fit the components of the adjusting system. Remember to replace the O-ring of this component with the O-ring that you find to the kit of the solenoid. Put some grease on the thread of the side valve, fit it in, and with the tool used to dismount it, you have to screw it in. We suggest to remove the circlip of a solenoid and use it to test all the Monroe CVSA shock absorber. If they work properly, remove the solenoid without the circlip and install a normal one. If they do not work properly, you can dismount them again, scrapping any solenoid. This is the solenoid used to make tests with any Seeger. You can mark it with a red point in order to recognize it. We pressurize the shock absorber insert the manometer, connect to the nitrogen, and pressurize. The rod will come up, regulate the pressure to the wish value. We suggest an inner pressure of 4-5 bars. More is not needed. Then remove the injector. At this point you can test the shock absorber. If it works, and you can remove the solenoid and to put the final one with the circlip.